Hello and welcome back to my series of videos working through the Sonic Pi tutorial. In this video, section 5.4, Threads. This might be a pretty long one, so strap in. Threads. So you've made your killer bass line and a fat beat. How do you play them at the same time? One solution is to weave them together manually. Play some bass, then a bit of drums, then more bass. However, the timing soon gets hard to think about, especially when you start weaving in more elements. What if Sonic Pi could weave things for you automatically? Well, it can, and you can do it with a special thing called a thread. Infinite loops. To keep this example simple, you'll have to imagine that this is a fat beat and a killer bass line. So we got loop, do, sample, drum, heavy kick, sleep 1, and end. So we got a heavy drum kick that we're pretending is a fat beat. And we've got loop, do, use synth, FM, play 40, release 0.2, sleep 0.5, end. And that's a sick bass line. We're just going to pretend. As we've discussed previously, loops are like black holes for the program. Once you enter a loop, you can never exit from it until you hit stop. How do we play both loops at the same time? We have to tell Sonic Pi that we want to start something at the same time as the rest of the code. This is where threads come to the rescue. So, we have in thread do loop do sample in thread do loop do sample such and such, and then loop do. By wrapping the first loop in an in-thread do-end block, we tell Sonic Pi to run the contents of the do-end block exactly at the same time as the next statement after the do-end block, which happens to be the second loop. Try it and you'll hear both the drums and the bass line weaved together. This is pretty neat. Now what if we wanted to add a synth on top? Something like loop do, so we've got the thread with the drum kick, we've got the loop do with the FM synth, and now we want to add in loop do, use synth, Zawa, play 52, release 2.5, phase 2, amp 0.5, sleep 2, end. Now we have the same problem as before. The first loop is played at the same time as the second loop due to in thread. However, the third loop is never reached. Let's review why that's the case. We have in thread, and the program executes all lines 2 through 5 starting at the same time that it starts line 8. And since line 8 just starts a loop, it's really line 9 that we're interested in, or maybe even line 10, because that's the first one that makes the noise. Okay. The third loop is never reached. It's down here because this loop is a black hole for code. We therefore need another thread. So then we have another in thread do. And I think I can do a trick here. Yep. That's nice. And then we've got the final loop to do the Zawa. Let's see how that sounds. That's kind of nice. I like that. That's fun. Runs as threads. What may surprise you is that when you press the run button, you're actually creating a new thread for the code to run. Oh, wow. This is why pressing it multiple times will layer sounds over each other. As the runs themselves are threads, they will automatically weave the sounds together for you. Scope. As you learn how to master Sonic Pi, you'll learn that threads are the most important building block for your music. One of the most important jobs they have is to isolate the notion of current settings from other threads. What does that mean? Well, when you switch synths using use synth, you're actually just switching the synth in the current thread. No other thread will have their synth switched. Let's see this in action. We've got play 50 and sleep 1. We've got in thread do use synth on TV303 play 50 end sleep 1 play 50. I see what's happening here. Ah, there we go. Type. Well, let's look at this. We have play 50 sleep 1. We have a thread. In that thread, we have use synth TC303 play 50, and then outside the thread, what are we going to do? We're going to go back to the default sound. Let's listen to that. Let's see. What did I type wrong? In thread do use synth. Oh, this is the wrong letter. Oh, use synth doesn't follow. Doesn't have a colon. Look at that scope. That's pretty fun. Let's look at that. Let's watch that again. Anyway, okay, so that's how that works. Notice how the middle sound was different to the others. The use synth statement only affected the thread it was in and not the outer main thread. Inheritance. When you create a new thread within thread, the new thread will automatically inherit all of the current settings from the current thread. Let's see that. So now we have use synth TV303 play 50 sleep 1 in thread do play 55 end. Now let's listen to that. Yep. Notice how the second note is played with the TB303 synth, even though it was played from a separate thread. Any of the settings modified with the various use functions will behave in the same way. When threads are created, they inherit all the settings from their parent, but they don't share any changes back. Okay, so if we did use synth, whatever, in here, that wouldn't affect us out here. Cool. Finally, we can give our threads a name. In thread name colon base do loop do use synth profit play chord. Well, this is a new fancy thing. E2 minor 7. But choose release 0.6 sleep 0.5 end. And what else goes on with examples? Okay, so we have another thread. In thread name drums do loop do sample elec snare sleep 1 and. Look at the log pane when you see this code. See how the log reports the name of the thread with the message? Let's see this. Thread bass, thread drums, bass, bass, drums, bass, 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 drums. Yeah. Nice. You know, these examples are starting to sound more like music. Look at the log pane when you run this code. See how the log reports the name of the thread with the message? Run 36 time 4.0 thread base synth profit release 0.6 note 47. There we go. Only one thread per name allowed. One last thing to know about named threads is that only one thread of a given name may be running at the same time. Let's explore this. Consider the following code. We have in thread do loop do sample loop amen sleep sample duration loop amen and that one. So run that. So go ahead and paste that into a buffer and press the run button. Press it again a couple of times. Listen to the cacophony of multiple amen breaks looping out of time with each other. Okay, you can press stop now. Let's try that. Okay, enough of that. This is the behavior we've seen again and again. If you press the run button, sound layers on top of any existing sound. Therefore, if you have a loop and press the run button 3 times, you'll have 3 loops, 3 layers of loops playing simultaneously. However, with named threads, it is different. In thread name : amen do loop do sample loop amen sleep sample duration loop amen end. Try pressing the run button multiple times with this code. You'll only ever hear the amen break loop. You'll only ever hear one amen break loop. You'll also see this in the log. Thread amen exists, skipping creation. Did you see that? Thread amen exists, skipping creation. Amen is already playing, so it's not creating another. This behavior may not seem immediately useful to you now, but it will be very handy when we start to live code. I can see that. Yeah, we want to, like, I want to add something new to this code. I mean, to the sound. I want to, like, baseline down here. I want to be able to run this whole buffer, but not have that thing loop over itself. Yeah, that's nice. That's good. Oh, and there we go. That's the section. That didn't take quite as long as I thought it would. All right, thanks for watching.